Today we are going to be finishing up our lesson about Boolean conditional statements and logical statements. So like the if statements, the else statements, those kinds of Python concepts. And then after that, we are going to go into loops. So if you understand conditional statements, loops should be a bit easier. I will also be posting some kind of assignment that way you could practice with conditional statements if you're not too sure about how to do it still. Last time I ended off with operators. So we talked about specifically, specifically I talked about the and, or, and not operators. So when we talked about and, the entire statement x and y, that would be considered true only if x is true and y is true. For or, one or the other just needs to be true, and not would be just the inversion of what that conditional statement is. Another important note that I do want to make right here would be this. Right here and right here. Do not use the ampersand or that vertical line. So if you are familiar with other coding languages like C++ or JavaScript or just Java even, normally you use the ampersand or two ampersands, or you use two vertical lines in order to indicate an and or an or. But in our case, these are bitwise operators. Bitwise operators we'll talk about much later, like maybe in like January, and we'll talk about what these do specifically. But for now, just avoid these two symbols. If you need to use and, or not, go ahead and just literally type out and, or, and not. So I want to talk about this is what we call a truth table. So this right here, like this table is called a truth table. So when you are given certain logical values here, so we can see that we have this right here, that's one logical value, true and false. So when you combine that into one specific value or one specific statement, true and true, you would just tell me what that output would be. Would that be true or would that be false? So before we do that, let's just talk about what and means. So in the previous slide, I had x and y, and specifically wrote that both conditions must be true for the overall statement to be considered true. So what do you guys think? If I have true and true, what would the overall statement be? Very good. This would also be true. What about for the second one? If I had true and false, what would that be overall? Perfect, this would be false. And if I had false, what if I had false and true? Yes, perfect, this would also be false. And finally, what if I had false and false? This would also be false. Very good. So you can see exactly what we said here. Both conditions must be true for the overall statement to be considered true. When we take a very close look at what I have for every single individual line, when I started off with both of them being true, both of these statements are true, A and B, that statement overall was true as well. Here I have a false. The moment we see that false, then the entire statement is false. Here is a false as well, so this statement must be false. And both of these are falses, so overall the statement A and B would be false as well here. I know right here we just talked about in general two different like A and B, but even if you have multiple things connected to each other by an and, as soon as one is false, the entire statement is false. If I give an example, if you like to sleep and you like warm things and you are quiet and you have 4 legs, then you are a cat. So for example, if you do, so for me personally, I like to sleep. That is a true statement for me. And I like warm things. So this is also a true statement. I would say I'm pretty quiet. So this is a true statement for me. But this one right here, you have 4 legs. For me, this is a false statement. Because this is a false statement for me, overall, this entire thing is false. It's not restricted to just having A and B. If it's A and B and C and D, overall, then this would be a false statement if you have just one thing in there that is false, which is very different from or. So or, we talked about this one in a different light, X or Y, and this says at least. So at least means one or more. So at least one means one or more. One or more condition must be true for the overall statement to be considered true. So now let's go ahead and fill out this truth table. I have true or true. What would this be? This truth value, very good. This would be true. We have at least one true statement. What if I have true or false? What would this one be? Very good. This one is also true because I still have at least one true statement. We have two here, and then I have at least one here still. And what if I have false or true? Perfect. This one is also true because I have that one true statement. I need at least one, and there it is. And finally, if I give you false or false, what would this one be? Perfect. This one is false. Whoopsies. This would be false. We need at least one condition to be true. In this case, this is a false and this is a false. We don't have any true statements. Therefore, this A or B condition is going to be false overall. Even if you have multiple things connected to each other by an or, as soon as one is true, then the whole statement will be considered true. So everything could be ridiculously false, but as soon as one thing is considered true in your entire connection of ors, then that means that your entire statement is true regardless. So for example, if you're in 9th grade, or in 10th grade, or in 11th grade, or in 12th grade, then you are in high school. So for many of you guys, I know there's a lot of 9th graders out there. So if you're in 9th grade, and then you can see everything else is connected by ors, or in 10th grade, or 11th grade, or in 12th grade, you already know regardless, because the 9th grade statement is true, and that this conclusion, you are in high school, is going to be true. However, I also know that there's some junior high students here, there's some 7th graders. So if you take a look at this, if you are in 9th grade, this would be considered false for the 7th graders, or in 10th grade, this is considered false for the 7th graders, or in 11th grade, this is considered false for the 7th graders as well, or in 12th grade, this is considered false for 7th graders as well. Then this right here, you are in high school, would not apply to the 7th graders because every single statement, every single proposition inside of that conditional was false. So regardless if it was an or not, that was just false. And finally, we have not. So not is the inverse of the conditional statement. If we take a look, the inverse just means you switch it. So if I have true, what would not true be? Not A, what would that value give me? False, very good. This one would also give you false because it's the opposite. So when I say inverse, I quite literally mean the opposite. So if instead of me having false as my input this time, what if I have, or instead of having true as an input this time, what if it was false? What would not false be? True, perfect. So it's literally, whoopsies, it's literally the inversion, literally the opposite. Oh my, everything deleted and everything erased. Let's write that in again. So this is false and this is true. Oh, well, it looks like I forgot to change that one. But let's go ahead and go into the order of operations. So order of operations, this is how it goes. So this starts off with number 1, parentheses, kind of like when you guys do order of operations in math. Please excuse my dear Aunt Sally, or I don't know which PEMDAS, I guess. The parentheses, exponents, multiplication, division, addition, subtraction. So a lot of this works exactly the same. So I have parentheses. Remember this symbol right here means exponents. This is my multiplication. I have two different kinds of division. This is also kind of considered division, except you get the remainder from it. So if you really want to, you can group all of these together. And then we have addition and subtraction. So PEMDAS works exactly the same as it would in math. It's the same thing in computer science as well in Python. But the things that come after it, the comparison operators, so the less than or equal to, greater than or equal to, and the not equal to, these are all considered one level. Kind of like in PEMDAS, we had parentheses on its own, exponents on its own, multiplication and division coexisted together on the same level of the order of operations. And addition or subtraction also coexist on the same level of order of operations. Just like that, we have all of our comparison operators that will coexist. The only thing that will differentiate them, which one would go first, which one would go second, typically is going to be going in left to right. So if I have, for example, oops, sorry about that. If I have, for example, let's say I have 3 plus 4 minus 7. Then typically what you do is when you do the math, you do 3 plus 4, which is 7, and then you do this minus 7 right here, which gives you a 0. You just normally go left to right when you have two or multiple things that, or multiple operations that are along the same level. After that, we have our three different operators, not, and or. So the nots will go first, then you will use the and then you will use the or. However, make sure that you still pay attention to these order of operations as well, because those will play an important role as the computation becomes heavier. Let's do a couple examples. So in case you guys forgot, I left the order of operations right here, and you could take a look at that. Oops. So let's try this one. So I have x is equal to 10. This is what I start off with. If x is greater than or equal to 0 and x is less than 10, then you want to print single. Else if x modulus 3 is equal to 0 or x modulus 2 is equal to 0, you want to print out 2, 3, or 6. Else, you are going to print out NA. So, which of these is going to print? Perfect, 2, 3, or 6. So let's go ahead and walk through this problem right here. So if x is equal to 10, I see this right here, x is greater than or equal to 0. So x is greater than or equal to, actually let's not use x, let's just go ahead and plug in that 10 right in there. So 10 is greater than or equal to 0. This is a true statement. So we're going to check the next one. X is less than 10. So I have to check, is 10 less than 10? This is false. 10 is not less than 10. 10 is equal to 10. So because this is an overall false statement because of the fact that this ended up being true and false, this statement being the true statement, this statement being the false statement, because they're connected together with an and I have one false, that means this overall is a false statement. Going back to our and, we see here that we have the true and false case is indeed false. So this true and false case is false. So overall, that entire statement is going to be false. So because it's false, we skip this body. And then we're going to go into the next case, which is the elif, the else if. So else if x modulus 3 is equal to 0. So x modulus 3 right here. If I do 10 modulus 3, this is equal to 1 because I get a remainder of 1. 10 divided by 3 gives me a remainder of 1. So 1 is equal to 0. This is a false statement. If I go into trying the other one, which is x modulus 2 is equal 0, then I have 10 modulus 2, which is 1. 10 divided by 2 gives you a remainder of 1. Or sorry, 10 divided by 2 gives you 0. Whoopsies, sorry. This is equal 0. 0 is equal 0. So this is a true statement. So despite the first statement being false, this 10 modulus 3 equal 0, my overall condition is false or true. And false or true is true. So because that statement means that this right here is a true statement, this is going to print. 2, 3, or 6 will print. And we also skip this else statement because we found something before it in that related or that family of condition statements that was true. Okay. So next one, let me erase the markings that I made here. That way you guys can see a little bit clearly. Okay, what about this one? We have A is true, B is false. If not A or B and not A, print true. Otherwise, so else, you would print false. What would this be? Correct, this would be false. So let's go ahead and follow through this order of operations. I'm gonna write this out down here. So I have this entire thing, writing it out. I have not A, so not A is true, so not true, or, and then we have in parentheses B, which is false, and not A, which is true. So according to our order of operations, we need to do our parentheses first. So the things inside the parentheses right here, false and not true. Now within the parentheses, we have to perform our own new order of operations. There's no parentheses, no exponents, no arithmetic, but the thing that has the highest priority would be the not. Not has the highest priority, as you can see here. So once again, we started off with the parentheses first, but inside the parentheses, the two operations that we have are not and. Not goes first, so we're gonna compute not true. Not true, we already said, is the inverse of true, which would be false. So this, the not true, is actually false. Now, within our parentheses, I have false and false because the not true has simplified to false. And we know that false and false is just overall false. So this right here would simplify to just false. So I'm running out of room. That's the reason why I'm going to take this and bring it right here and finish it right here. So not true or false. So this is what it's simplified down to. Now looking at our order of operations again, we have a not and an or. So not is here and or is here. Not will be computed first. So not true, we already know is going to be this right here is false. So I have false or false. And false or false is false. So this right here is a false statement. So normally if something is true, you would print true, but this time we got false. So because it's false, we're going to print out false here. So the thing that will print out is going to be false. Whereas this one was 2, 3, or 6. I believe I have one more. I have one more, but it's currently covered. So I'm going to erase this again. All right. Which of the following is not a condition to check if x is in the range of -1 to 5 inclusive? So this is a multiple choice test, something that you could potentially see on an AP test actually. So let's go ahead and take a look. So the first one is x is greater than or equal to -1 and x is less than or equal to 5. B is x is not x less than -1 or x is greater than 5. C is -1 is less than or equal to x, which is less than or equal to 5. And D is not x is greater than or equal to -1 and not x is less than or equal to 5. Now this is a little hard one, so I'm going to give you some time to think about it. And I would like to get a few people's answers. Yeah, there's more than one answer to this. So if you chose B and D, this one is correct. B and D. These are both the correct answers. So let's go ahead and talk about this. I'm going to be doing this a little bit more numerically, kind of like math. So let's go ahead and try this. So for choice A, we have x is greater than or equal to -1 and x is less than or equal to 5. So here's -1 and here is 5. So when I have, oops, sorry about that. When I have x is greater than or equal to -1, that's including -1 and going this way. Those are all numbers greater than or equal to -1. And then I have this in here, x is less than or equal to 5. So I start from the 5 and I want to go this way. The overlap between them occurs right here, between -1 and 5, both inclusive. So A is correct. And then for B, let me try to confirm if B is the correct answer or not. I have -1 and 5. Taking a look at this one, I have not x is less than -1. So let's break this down into two smaller parts. First of all, let's just look at the x is less than -1. So, oops, sorry about that. X is less than -1 would be typically here. So this and then going that way. Everything less than -1. We don't include -1 because it's not equal to -1, just less than -1. So not x is less than -1 would be this one right here. So when I include the nots, so the inversion, we start here, including -1 and go everything to the right, everything greater than -1. Then I have this right here, this one, x is greater than 5, which starts from 5 and goes this way. So overall, sorry, I keep pushing that button. So overall, when I look at my overlap, or sorry, not my overlap, if I look at this word or means anything that it touches, anything that my condition, not x is less than -1 and x is greater than 5, everything that those touch. Not x is less than or equal to -1 is right here. And then x is greater than 5 is right here. So everything that I colored in red would be the set of numbers that B is referring to, which is not exactly between -1 and 5. So this one would not be the correct answer. Now, if I have C, so we have C, I think I'm gonna do C over here because I'm running out of space. And I have -1 is less than or equal to x, which is less than or equal to 5. Oops. In math terms or in math notation, you would normally see this as -1 less than or equal to x or less than or equal to 5. So this one's very specific to Python. This is specific to Python. You cannot do this in most languages. In fact, the AP test probably won't even have this notation because it's predominantly incorrect for most of the languages. Python is just one of the languages where this will work. So I just want to differentiate that with you guys. So normally, instead of writing it like this, like we did in C, which is, remember, specific to Python, you typically want to write it like you did in A, which is how you would write it in pretty much any other language. So if you were to see this on the AP test, you would most likely see it in the form of choice A as opposed to the form of choice C. C, however, is overall correct for Python specifically, because if I have my -1 and 5, this part right here indicates that I want all numbers that are greater than or equal to -1. So greater than or equal to -1 would start from -1 and go to the right, whereas everything here, so this thing I circled, x is less than or equal to 5, would start from here and then go to the left, everything that's less than or equal to 5. So the overlap between them, because this is a compound inequality, would be this right here, between -1 and 5. So our solution for C, or our answer choice C, is a valid solution. And finally, choice D, which I'm going to write down here, we have not x is greater than or equal to -1. So first off, let's figure out what x is greater than or equal to -1 is first. Here's -1 and here's 5. So normally x is greater than or equal to -1 would be this, not this line right here, or this from -1 inclusive, and then you would go to the right hand side. But we want the opposite of that. The opposite of that would be this part right here. So this right here is not x is greater than or equal to -1. Now, if you look at the second part, which is x is less than or equal to 5, this right here, not x is less than or equal to 5, focusing in on the x is less than or equal to 5, we have this. But if we want the opposite, the reverse of that, because this is an inversion, because we have the not there, we start with an open circle from 5 and go out this way. So just to make it a little bit clearer, I'm going to highlight the portions that were x or not x is greater than or equal to -1, which is this part, and not x is less than or equal to 5, which is this part right here. And means that both things have to be true. There is no number where both of these statements are true. There's no number that overlaps between them. So this one right here, obviously not it, first of all. But second of all, this will just always be false. So this is like a weird case where no matter what you plug in, it'll always be false and it'll just never work. So just be careful with your order of operations. The homework that I'm going to be sending out will be very heavily focused on the order of operations. So it would be good practice if you thought that this was a little bit confusing. More practice. So we're gonna do truth table. So let's go ahead and do this. We already filled out up to here. So up to here was filled out when we did the truth tables with the and or. So we're just gonna make things a little bit more complex by throwing in more potential things that you can see. All right, I have A is true and B is false. So A is true and B is false. Therefore, when I did A or B, I got true. So what would be not A or B? Perfect. This would be false, because we would take A or B and invert it. So our current A or B statement, which was true, our current A or B trait was true, but then it inverted, so it became the opposite, and now it is false. What about in the next statement where we had A is true and B is false? When we did A or B, that was true. So when we invert it, what would we get? Perfect. We get false again here, because this A or B, which was true, inverts to become false because we have that not here. What about the next one? So A was false, B is true, A or B is true. What would not A or B be? Yes, this one would also be false. And finally, we have A is false, B is false, A or B is false then. So what would not A or B be? Perfect, this one would be true. Very good. Let's move on to the second part of this truth table, which is filling out not A, oopsies, filling out not A and filling out not B. That should be capital B, but oh well. What is not A? So if A is true, because I'm using this line right here, so like everything in this row will be using the same, everything in this row will be using the same A value. What would the value of A, or not A, be here? And you guys are saying false? Perfect. So this one right here would be false. Or what about my second row for not A, where A is still true? Perfect. This one would also be false. And then what about the next one? My value of A is false now, so what would not A be? Perfect, this one is true. And then what about my second A, or my second false value for A? If it's not A, very good, this is also going to be true. Now we're gonna go ahead and do the B. So not B, where B is true, what would that be? Perfect, this is false. What about the second one, where my B is false this time? What would not B be? Very good, this one is true. And then my next one, where B is true again. So what would not B be? Very good, this one is false. And finally, I have B is false. What would not B be? Very good, this one is true. Now we've reached our final column, where we have something a little bit different, not A and not B. So fortunately, we already calculated what our not A is and what our not B is. So what would not A and not B be for our first row? So this would be false and false. So for this one, I have my not A and my not B. So not A for this was false. And and I have a not B, which is this one, false. What would that be? Very good. This is false. So overall, this is false. So using that same logic, what would the next row be, where I have A is true, B is false, therefore not A is false and not B is true. What would not A and not B be? Perfect. This one would also be false. So I don't think I have a laser pointer on here. It would be really convenient if I did. Okay, but the reason why this one is false is because I have my not A, which is this right here, and my not B, which is this right here. So if I have false and true, this should output false. So that means for the next one, if I have not A and not B for this row, where not A is true and not B is false, what do I get? Very good. This one is also false because I have true, which is my not A, so I plug that in into this not A, and false, which is my not B, so I plug it into this not B. So not A and not B, which would mean true and false, outputs a false. So this overall statement would be false. And finally, I have my last row for this truth table, not A and not B, where not A is true and not B is true. So what would my overall statement be? Very good. This one would be true. Let's see the next one, next truth table. I know that this is a little bit lengthy, but trust me, there's a good reason why we're doing this right now. Now I have not A and B. So when we talk about not A and B, we're doing the same kind of thing that we were doing before, where we have our A and B already provided for us right here because we've evaluated that truth table in an earlier slide. Now for not A and B, where A is B, or A is true and B is true, therefore A and B is true, what would not A and B be? Very good. This one would be false. Because the inversion of true is false. Then what about the second statement where we have A is true, B is false, and then we have we have A and B, which is false. Therefore, not A and B would be true. Very good. So this one is true because for my not, because I had false, oops, did not mean to cross that out. When I use my not, or I use my false, and then I inverted it, that should have given me true. So for the next row, where A is false and B is true, therefore A and B is false, what would not A and B be? Perfect. This one is also true. Oh, I messed up the colors. It's fine. And then finally, the false and false would give you false. So if you invert that, what would you get? Perfect. So this one is also true. Now we're gonna move on to our next two columns. Actually, the next two columns, I'm just gonna copy what I have from right here because they're exactly the same. They're identical. My ordering for the A and B's on the very leftmost side, right? So right here and here are exactly the same here and here. We're doing the same operation, not A, not B. Therefore, the two columns are going to be exactly the same. So this is false, false, true, true, and this is false, true, false, and true. Now I have not A or not B. So this is kind of like what we did in the truth table above, where I'm plugging in the values that I've derived from over here. So I'm going to be taking, hold on a second, I'm taking these and using them here. So not A or not B for that first row, where not A is false and not B is false. What would this give me? Perfect. This one would give me false. False or false, we already know should be false. So this would give me false. In the second row, however, I have false and I also have true. So what is false or true? Perfect. This one is going to be true. And then in the third row, I have not A or not B, so true or false. What would that be? Perfect. And then finally, for not A or not B, I have true or true. What does that give me? This would also be true. Perfect. All right. So the reason why we did this is because of a very special rule, it's a very special law called DeMorgans Law. So DeMorgans Law actually is very specific. It's talking about the inversion of certain conditions, specifically conditions with ands and or. So taking a look at what we have here, hopefully you can see that this column right here is identical to this column. We have our false, false, true, 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 and true. Whereas up here, I have false, 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 true, and true. So taking a look at it where it's a little bit more cleaned up, we have DeMorgans Rule. So DeMorgans Rule is specific. It's like what we just said before. Not A or B is equivalent to not A and not B, whereas not A and B is equivalent to not A or not B. So pretty much what happens is if you are inverting a conditional, so not A or B, you distribute. It's like a distribution. So it's not A, and we have a not B, but the thing that goes in between them is not the same. It's not or. You flip it. So if it was an or, it becomes an and. And then if you're doing not A and B, when you simplify it out and you distribute the not, so not A, and then we have not B, instead of filling that in with the and that was here prior, it flips into an or. So instead of you having not A or not parentheses A or B, this will simplify to not A and not B. Instead of you having not A or not parentheses A and B, this will simplify to not A or not B. This is very important to remember because Python is like English. So when you try to write out a condition and you're just talking in English, you can say something like a vowel is, or sorry, a consonant is not A, E, I, O, or U. So when someone does that, consonant is not A, E, I, O, or U. A lot of people will literally code it out like this. They'll say not A, E, I, O, or U, but really when you use DeMorgans Rule over this, what this means is something like this, not, and then A, E, I, O, or U inside of the parentheses. So how you should actually code it, if you decide to rewrite it, would be not A, and not E, and not I, and not O, and not U. That's actually what it's referring to instead. And this is what DeMorgans Rule will show. Okay, I know that was a little bit of a lengthy rule. Another takeaway of what I just said, or just what I just wrote, is that DeMorgans Rule distributes over multiple ands and multiple ors, not just one or and not just one and. So you can see that here, I distributed technically over 1, 2, 3, 4, 5 different, or 1, 2, 3, 4 different ors. So instead of just focusing only on one, I was able to focus or just work out on all of the ones that are listed there. Okay, so I do have this practice for you guys, but because we don't have time, we only have 13 minutes. Unfortunately, I don't think I'll be able to show you a whole bunch of code for this. I do want to get into the loops, or at least introduce loops to you guys, because that is going to be our next topic. So give me 1 second to pull up the next PowerPoint, and then we'll get started. So the next topic is about loops. So loops are, well, actually, let's just talk about what loops are. So we often want to repeat a task, but do so in a concise way. So if I told you to print out the asterisk 100 times on separate lines, you probably don't want to type out print asterisk. Oh, I did this wrong also. Oopsies. Timeout. I did a bad thing. Don't do this. I forgot my parentheses, or sorry, my quotation marks. So if you were to print out asterisk, you definitely don't want to type out print asterisk like 100 times. Do not do that. So if you're doing something repetitive, it's often more efficient to use a loop. So loop is used when you have a block of code that you want to repeat multiple times. And it's also used for iterating over a sequence. For our class, for the first part of our class at least, we will be using a loop for this only. Later on, maybe in 1 month, we'll do this. But for now, we're going to be focusing primarily on executing a block of code that you want to repeat multiple times. So for example, if I ask you like how do you brush your teeth? You typically don't say like, oh, you take your toothbrush and put toothpaste on it, and then put the toothbrush in your mouth and brush up, brush down, brush up, brush down, brush up, brush down. You normally don't say that. It's giving me the proper instructions, but you don't want to literally say up, down every single time. Instead, you could say brush 100 times before you rinse your mouth. That's pretty much what our loop will be doing, instead of you writing out each instruction sequentially, like you can see done here in our code, where we print the asterisk 100 times. You are instead going to write it in a way that you just have it print, and that'll be it. The first loop that we're going to be talking about is a while loop. So a while loop, hold on a second, I'm just going to add in the asterisk here, or sorry, the quotations here, because this is bad with all the quotations. So for the while loop, when we speak in English, when we say print out, like if I tell you to print out the number of asterisks, you would say we want to print the asterisk while we have less than 100, I guess 100 printed. That keyword while is going to play a huge part to our loop when we go ahead and code it in. If you're familiar with coding already, you will know that there's while loops pretty much in every single language, whether you're using JavaScript, Java, or C++, even in Python, we have while loops. So a while loop is going to be a loop that's written in a way such that it is while, and then you have a condition following it. So this loop will run while the condition is true. How much time do I have? Okay, I have 9 minutes. So there is an action that must be done while the condition is true. So here, when we talk about what's going on here, I said while we have less than 100 asterisk printed, then we want to print another, or print the asterisk. Talking about this, we have less than 100 asterisks. This is our condition, whereas the print the asterisk, this is our action. So let's go in a little bit deeper into while loops now that I've just introduced to you what the concept is and why we're going to be doing this. So here is your first while loop. There's 4 components to a while loop. Let's go over each one. First of all, oops, wrong thing. First of all, we have our counter initialization. This will keep track of the number of times the loop has run. Otherwise, if you don't have something counting the number of times that the loop has run, you don't know like when you need to stop or when you need to keep going. We have our condition. This determines if the loop will continue to run or if it should stop. So when we were at this center here, we have less than 100 asterisks. That is our condition. This will tell you if you have enough asterisks or if you don't have enough asterisks. Whereas we are on top of that, we talked about we need a counter initialization, something that will count. So we need a counter here that will count the number of times we have printed our asterisk. So we've already talked about 2 of the components of a while loop. Talking about the third now, we have our body. So this is what should be executed for every iteration of a loop. So in this case, this is like our action. What do we want to happen every single time our loop runs? So our action is going to be important for this. And finally, we have an incrementer or decrementer, pretty much something that updates the count. If you don't have an incrementer or a decrementer, then you run the risk of having an infinite loop. An infinite loop is exactly what it sounds like. It's a loop that runs forever. Fortunately, most computers or just most IDEs or anything you run your code on have some kind of fail-safe. They have something built into it where it could detect if your code is going to end up having an infinite loop, and then it will stop the code or the program from running, so it doesn't just overwork your computer. So most of the time, you could just avoid having your computer to do any of that if you have all 4 of these components of your while loop. So let's explore this one right here, and then I think that's just going to be it. All the slides I covered in this PowerPoint, the loop PowerPoint specifically, I will be covering again next week because we just didn't have enough time to go over everything in as much detail as I would have liked. So don't worry too much if you have no idea I'm talking about the loops yet. It's fine. I'm going to be going over it again next week. I just still want to introduce a topic to you guys so that I don't fall too behind in what we're talking about for this year. So first of all, we had our counter initialization. So our counter initialization, we can see here, this right here is a counter initialization. So I initialized my count to 0 because before my while loop started to run, I had no asterisks printed out. I had no stars, no whatever you want to call it. None of those have been printed out. So I initialized my count to 0. So while count is less than 100, this is my condition. I know that I want to print out this asterisk a set number of times, which is so because you already know, it's great to use a while loop because you already know how many times you want to do it. You know what the condition is to end the loop. So we have while count is less than 100 because once you've reached 100, you don't want to print any more asterisks. This right here would be considered your body. This is the action that you want to do. So your body could actually be more than one line. It's just that here our code is so simple where we only need to do one thing, which is print the asterisk. And we don't really need to include a whole bunch of stuff in it. So we just did print the asterisk, and that was our body. And finally, we have our updater. So our incrementer or decrementer, in this case, it's an incrementer because it increments our count by 1. If we don't have an incrementer, what ends up happening is that count will stay 0 forever because count never changes. So if that count is equal to count plus 1 is gone, if this was gone, then nothing updates count. Count will stay 0 forever. 0 is always less than 100, and now you have an infinite loop because count will always be less than 100. So it always prints out the asterisk. And now you have your program running forever and ever and ever until either you manually stop it or your computer decides that that's enough. So I have we'll stop there for now, or we'll stop there for today. And I'll continue going over these slides next time.